You have probably already heard someone say, "I need a better graphics card for gaming," or "AI needs a lot of GPUs," and wondered, what even is a GPU? Why does it sound like it runs everything cool in tech? Whether you're into AI, gaming, Netflix, TikTok, or just curious about how your devices work, today I'm going to break it all the way down. No jargon, no headache, just the magic of how one chip changed our digital world. Let's start with your computer's brain, the CPU, or central processing unit. Think of it like a master chef. It is smart, versatile, but cooks one dish at a time, really well. Now imagine a GPU, the graphics processing unit, as an army of line cooks, each chopping, grilling, and prepping many ingredients at the same time. That's the difference between both. CPUs are great for general tasks, like emails, documents, or web browsing. But GPUs? They shine at handling lots of small tasks simultaneously, like rendering 3D graphics, training AI, or processing video. When watching a Netflix video, for example, at first glance, this seems like one task, but here's what's really happening. The video is made up of millions of frames. Each frame is made of millions of pixels. Each pixel needs to be decoded from a compressed format like H.264 or HEVC. Each pixel is then converted into color values, notably red, green, blue, and finally rendered on screen. The GPU assigns thousands of its chef cook called core to work on thousands of pixels at the same time. This is a perfect case of parallelism. Each core says, "Hey, I'll handle this tiny rectangle of pixels." And they all work together to display the frame in real time. That means 30, 60, or even 120 frames per second. Now, what about the CPU? Does it really have only one master chef? In fact, CPU doesn't just have one core, it usually have a few. So technically, there's not just one master chef in the kitchen. Modern CPUs, like an Intel i5 or AMD Ryzen, typically have 4 to 16 cores. That means they can handle 4 to 16 tasks in parallel, but only if those tasks are split up the right way. So when one say a CPU does one task at a time, this is a simplification of a deeper truth. Let's say you open your email. That might seem like a single task, but behind the scenes, your CPU is breaking it into pieces. Core 1 checks your internet connection. Core 2 decodes the email message. Core 3 draws the email layout on your screen. Core 4 plays that ding, the notification sound. These tasks cannot be parallelized since they depend on each other. You can't decode the email until the data arrives. You can't show it on screen until it's decoded. That means the CPU handles them step by step, sequentially in a quick succession. It's not truly parallel, it's more like juggling. When it comes to a Netflix video, as we said earlier, or rendering 3D graphics, you're not just loading one email, you are updating millions of pixels, calculating colors, shadows, and movement every frame. A CPU can try, but it is not built for that kind of workload. That is why games in the 1990s looked blocky or pixelated. CPUs were trying to do all the heavy lifting, and it just was not enough. And even earlier, remember those old black and white videos? That was not just an artistic choice, it was a hardware limitation. Computers simply couldn't process rich visuals in real time. So engineers created the GPU, a chip designed to handle massive amounts of data all at once, in true parallel. And that changed everything. Fast forward to today, GPUs have become powerful mini supercomputers useful for games, AI, crypto, or even self-driving cars. Ever played Fortnite or Call of Duty? Those realistic shadows, smooth frame rates, and explosions, that's the GPU at work. AI models need to learn from millions of examples. Where a CPU would take weeks, a GPU gets it done in hours. From YouTube thumbnails to Netflix 4K streaming, GPUs handle the visuals you enjoy every day. Miners use GPUs to solve puzzles and earn digital coins, like Bitcoin and Ethereum. Companies like Tesla use GPUs to help cars see the road and make split-second decisions. If you're buying a computer and wondering about GPUs, here are a few things to know. First, the type of GPU. There are two main types of GPUs, integrated and dedicated. Integrated GPUs are built into the CPU, good for everyday tasks. Dedicated GPUs are separate, powerful, and built for gaming, AI, video editing, and 3D rendering. Second, pay attention to the amount of video RAM, also called VRAM. This is the GPU's memory. More VRAM means better handling of big images, 4K video, or large AI models. And finally, consider the main players in the GPU market. NVIDIA offers the GeForce series for gaming, and the Quadro series for professional applications such as 3D rendering and engineering design. AMD produces the Radeon series, which serves both gaming and creative workloads. Intel, traditionally known for integrated graphics, has more recently entered the dedicated GPU space with its own line of graphics processors. Want to compare GPUs to find the best bang for your buck? A great place to start is a benchmark site like Passmark or User Benchmark. Here, we are using Passmark as an example. To begin, go to the Benchmarks tab, then click on Video Card Benchmarks. This takes you to a dedicated page where GPUs are ranked by performance. Now, if you want to directly compare two or more graphics cards, go to the left-hand column and select Compare. Type the names of the GPUs you're interested in. Let's, for example, compare the GeForce RTX 4060 Ti and the Radeon RX 7600 XT. As you can see, both are added to a list to be compared. Now we click Compare. And here's the comparison table. You can see key specs like price, power consumption, clock speed, and memory. One helpful metric here is the G3D rating, a general performance score. In this case, the RTX 4060 Ti scores 22,749, while the RX 7600 XT scores 17,153, about 24% lower. Also notice the green plus add button at the top right that lets you compare even more GPUs side by side. Benchmarks don't tell the whole story, but they're a great way to compare raw power and help you choose the right GPU for your needs, whether that's gaming, editing, or AI. GPUs started as helpers for gamers. Today, they power the technologies shaping our future: AI, robotics, medical imaging, space exploration. So the next time you see a graphics card, don't just think of games. Think of it as a powerful engine, bringing pixels, intelligence, and innovation to life. If you found this video helpful, give it a thumbs up, subscribe for more tech made simple, and drop a comment. Tell me what tech concept you would like me to explain next. Bye-bye.